The researcher claimed that the average income of the town's residents is at most $60,000. You surveyed 40 residents from the town and found that the average income is $63,500 and the standard deviation is $12,000. Assume we already did the first step of the hypothesis test and determined that the null hypothesis is mu equals 60,000. The alternative hypothesis is mu greater than 60,000. Compute the test statistic for the hypothesis test. This is the only thing we need to do in this particular problem. To compute the test statistic for the hypothesis test for the mean, we need to determine whether sigma is known or sigma is not known. The reason why we need to determine whether sigma is known or unknown is because the procedure for each of these two cases are different. Specifically, for sigma known, we would compute the z-test statistic, and when sigma is unknown, we would compute the t-test statistics. And so they are slightly different. Regardless, we still need to translate these numbers into symbolic form. The claims is that the town's average or the mean income is 60,000. So this is mu. This is the claim about the population. So that is the parameter where we label mu. 40 residents in the sample. So n equals 40. That is the sample size. $63,500 is the mean of the sample of 40 residents. So we would label it at X bar. So X bar equals 63,500. And this standard deviation is the standard deviations of the sample of the 40 residents. So this is S equals 12,000. Because of this, we know that the standard deviation of the population is not given, and so sigma is unknown in this case. Therefore, the test statistic that we would need to compute is the t-test. But before we compute the t-test, keep in mind that the hypothesis test rely on the sampling distribution, so we would need to check normality. For the mean, we just need the sample size to be greater than 30. In this case, n equals 40. So yes, the condition is satisfied. In this case, we need to check the sample size because the problem does not mention the normality of the distribution of the income at all. Now that we figured out everything, we just need to compute t-test statistic where t equals X bar minus mu over the standard error, which is S over the square root of n. There is no sigma here because sigma is unknown. And we have the numerical values for all of these notation. X bar is 63,500 minus mu is 60,000 divided by S is 12,000 divided by the square root of n is 40. All we need to do now is to put this in a calculator, the entire expression in a calculator, and we will get the t-test statistic 1.845, where we round it to 3 decimal places.